Okay, picture this. You're sitting in the cab of a massive locomotive, just hurtling down the tracks. Now, typically you'd be surrounded by this chaotic array of flashing lights, confusing bells, and really harsh alarms constantly demanding your attention. But what if, instead of just loudly beeping at you, the train actually spoke to you? Like, what if the technology inside that cab could hold a calm, intelligent conversation with you, anticipating problems before they even happen?
Right? Think about the power of hearing exactly that. It completely changes the entire dynamic of driving a train. You are no longer just reacting to some isolated buzzer, you're interacting with a highly intelligent assistant. This isn't just an advanced alarm system triggering a red light on a dashboard somewhere. This is Victoria. She's a natural language AI co-pilot that processes complex environmental data and gives you immediate, actionable advice.
Welcome to The Explainer. I absolutely love taking these massive, complex systems and breaking them down, and today we are unpacking something truly fascinating. We're going to explore the evolution of the Victoria Locomotive Copilot and the Titan Smart Railway Platform. Basically, we're watching AI evolve from a helpful little voice in a single cab to the centralized, highly conscious brain of an entire global railway.
Okay, let's dive right into this. Here is our roadmap for today. 1. Meet your AI copilot. 2. Smarter driving and vision. 3. Connecting train to station. And finally 4. The brain of the railway. Let's get started.
Starting with part 1. Meet your AI copilot, the intelligent assistant right there in the cab.
Now, just to be super clear right up front, today Victoria isn't actually driving the train. She's acting as an ever-present, brilliant advisor, exactly like a co-pilot on a flight deck. But just look at the sheer web of data she's digesting simultaneously. She takes in live feeds from visual and thermal cameras, she monitors GPS and wheel sensors, constantly checks engine temperatures and brake pressure, all while cross-referencing track databases, live weather reports, signal systems, and even passenger loads. She's essentially solving this massive real-time puzzle so the human engineer doesn't have to juggle it all in their head.
You can really see the night and day difference here in the driver's seat. The old way is basically a chaotic guessing game. Engineers are forced to interpret a dozen different screens and decipher all these various bells and alarms, which, honestly, is kind of like flying a plane blindfolded. But the new way? It's simply conversational assistance. When an alert flashes, the engineer can just ask, "Victoria, what's wrong?" Or, "Victoria, why are we slowing down?" It brings this incredible, much-needed sense of calm and clarity to the cab.
I mean, imagine the sheer relief of getting this specific answer back. Instead of a flashing red light that causes an instant spike in your heart rate, Victoria provides a precise diagnosis and a recommended course of action. And crucially, notice how she adds that the current risk is low. That is the true value of this AI. It isn't just flagging errors, it's actively triaging anxiety for the human operators. It completely prevents cognitive overload, letting the driver stay 100% focused on the tracks ahead.
Moving into part 2, smarter driving and vision, seeing and optimizing the route.
So what does all this intelligence actually mean for moving a massive train? Well, once you have an AI that understands the train's underlying mechanics, it acts as a highly advanced driver advisory system. Victoria is continuously calculating the optimal throttle, braking, and coasting distances for energy optimization, and we are talking about a 5 to 15% reduction in fuel consumption here. To put that into perspective, for a major railroad operating massive fleets, a 15% savings in fuel is an absolute game changer. We're talking millions of dollars saved, a huge drop in carbon emissions, and ultimately cheaper logistics and goods for everyone, literally just from optimizing how the train coasts.
But here's the coolest part. She isn't just crunching numbers in the background. She is physically looking at the world. Through her Vision AI, Victoria continuously scans the tracks ahead for people, cars, animals, fallen trees, rocks, snow, flooding, track damage, you name it. She literally becomes the ever-watchful eyes of the train. She never blinks, she never gets distracted, she processes visual hazards way faster than humanly possible, and hey, she never needs a coffee break.
And this brilliantly illustrates how the transition from spotting an obstacle to solving the problem is instantaneous. When Victoria spots a hazard, she doesn't just log it in some database, she translates it into immediate, potentially life-saving advice. If a car is stuck on a level crossing ahead, she instantly calculates the exact distance, speed, and weight of the train and calmly announces, "Automatic emergency braking recommended."
Okay, part 3. Connecting train to station, the Titan differentiation.
Now, this is where we zoom out and shift from a single smart train to a massive smart ecosystem. Look at all the information Victoria has access to before the train even moves an inch. By integrating directly with the Titan BioGate and Station AI, she knows exactly what is happening out on the platform. She knows if passengers are missing, if wheelchair passengers need a little extra time, the baggage status, station congestion, the whole shebang. The train is no longer a blind vehicle just pulling into a station. It's seamlessly networked with the platform itself.
This means the pre-departure sequence becomes beautifully synchronized. The engineer just listens to Victoria confirm the pre-flight checklist. 1. All passengers accounted for. 2. Doors locked. 3. Platform clear. 4. Ready for departure. It makes the train and the station operate as one unified, incredibly safe system, totally eliminating the guesswork and communication delays that usually plague departures.
Which brings us to Part 4, the brain of the railway, toward SAE Level 4 and beyond.
Now, if Victoria can see the tracks, advise on the throttle, and talk to the stations, what is the logical next step? Autonomy, right? Specifically SAE Level 4. And for context, this is the exact same autonomy standard used for self-driving cars on our roads today, just applied to massive locomotives. It defines a state where Victoria actually takes physical control of the throttle, braking, and traction motors under specific controlled conditions, like complex rail yards, while a human engineer is still sitting right there to supervise. It completely grounds this highly futuristic tech in recognized safe industry standards.
Let's recap how this all comes together. Look at how this complete evolutionary timeline builds. We've gone from a simple AI copilot in Phase 1, pushed through the advisory and vision AI phases, integrated with the station in Phase 4, touched on the autonomous train in Phase 5, all culminating in Phase 6, Fleet AI. This is the moment where Victoria evolves from assisting a single crew to coordinating the entire network.
Just pause for a second and consider the staggering scale of Phase 6. At this level, Victoria isn't just running one train. No way. She is actively coordinating 100 locomotives, managing data from 200 stations, and interacting with 10,000 Titan BioGates simultaneously. Think about why this matters. If a massive storm hits one side of the country, she can automatically adjust ticketing, routing, and maintenance schedules thousands of miles away in real time. She truly becomes the central nervous system of the railway.
And structurally, it forms this brilliant 7-layer architecture stack. You can kind of think of it as the journey of a single data point, right? A single scan of a passenger's digital ticket at Layer 1 flows instantly through the BioGates, up into the station and locomotive AI, pushes right up into the railway cloud, and surfaces milliseconds later on an executive dashboard up at Layer 7. Everything is perfectly integrated from the commuter waiting on the platform all the way up to the executive suite's operational metrics.
So the crucial point here is that this architecture creates a massive strategic moat. The current industry standard is frankly highly fragmented. Most rail tech companies focus on just one isolated area, like only doing driver assistance or only doing predictive maintenance. But Titan's vision? It connects the stations, the locomotives, the passengers, and the operations all through one unified conversational AI platform. Having that fully conscious network is just an unparalleled advantage.
Ultimately, watching this evolution leaves us with a pretty profound thought as we transition from human-driven machines just reacting to loud alarms into a fully integrated, conscious railway ecosystem managed by artificial intelligence. When the passenger gate, the station, and the locomotive all think as one unified entity, who is really driving the train? It's a massive shift in how we think about transportation. Thanks for joining me on this explainer today. I really hope it gave you a crystal clear view into the future of our railways. Keep asking questions and keep learning.